Assalamu alaikum students. Welcome to Hussaini school. I am your chemistry tutor and today I am going to teach you one of the most important chapters in the chemistry, that is acid, base and salt. This chapter will be divided into three parts. One part will be covering acid and the second part will be covering base. The last part will be salt. There will be a discussion about some important salts that we see in our day-to-day life. Now today what I am going to talk about it is acid. So what is an acid? Actually what happened thousands of years ago, people were consuming food as today we consume food. At that moment, people when they consume food, they notice that some food tastes sour. Their taste is sour. Then there was a confusion a bit. Why this sourness is in food? Then this was solved by a very brilliant scientist, Robert Boyle. Robert Boyle, what did? He said that these food items that taste sour actually contain substances that are called acids. Acid is derived from a Latin word acidus, which means sour in taste. But you see that from chemistry point of view, this was not the perfect picture of an acid. It was not based on the chemical nature or chemical structure of a substance. What is an acid? What should we call an acid? Then what happened? Another scientist came who gave a perfect picture. The first picture of an acid was Arrhenius. Arrhenius, what he said? He said, when an acid is dissolved in water, when an acid is dissolved in water, what happens? Any type of acid. What type of acid it is? When it is dissolved in water, it will generate a common ion, that is hydrogen ion. All the acids. What Arrhenius said, Arrhenius gave us first scientific definition, definition that was based on the chemical structure or the chemical nature of a substance. What he said, when an acid is dissolved in water, it will produce hydrogen ion. It will produce hydrogen ion. No, for example, if we take an example here, we will take example of HCl, hydrochloric acid, a well-known example. What happens when we put this hydrochloric acid in water? So what happens there? It will get ionized or dissociated into H plus aqueous and Cl minus aqueous. Now see here what happens. We took the example of HCl and when we dissolved it in water, it got dissociated, it got ionized into H plus and Cl minus. And you also noted that here AQ, what does it mean then? It means aqueous means water. It means the H plus ion that is produced when the acid dissolves in water. It is surrounded by water. It is not lonely there. It is surrounded by water. In chemistry, we put in nutshell that H plus aqueous. It means hydrated hydrogen ion. So what is the definition? The definition is simple. When an acid is dissolved in water, it will produce always H plus ion and an anion. For example, we'll take another example. We take sulfuric acid H2SO4. It's also an acid. So dissolve it in water. When we dissolve it in water, what happens? It will give H plus ion and sulfate ion 2 times. You see that here what happened? When we dissolved HCl in water, it produces H plus ion. And when we dissolve sulfuric acid in water, it also produces H plus ion. Notice this point, H plus ion, H plus ion. What is changing? It is the only anion that is changing. Anion is changing. That means acids are the substances which, when dissolved in water, will produce H positive ion. This was the first, the scientific definition that was given by one of the great scientists, Arrhenius. What is the definition? When an acid is dissolved in water, it will always produce H plus ion. Now the question arises, can an acid will show acidic character in a state of water? Simple question. Can an acid express itself without water? No. The reason is no. Why is the reason? The reason is simple. When you dissolve HCl in water, hydrochloric acid in water, after dissolving in water, it produces H positive ion. It is because of this H positive ion it is showing acidic character. If there is no H positive ion, it will not show acidic character. Here, sulfuric acid, when it is dissolved in water, it gives H positive ion, and this H positive ion is responsible for its acidic character. It's generally asked question in your 10th board examinations. Can an acid show acidic character without water? No. Acid cannot show acidic character without water because there will no be ionization. When there will no be ionization, there will be no formation of H positive ion. Clear? Now we will be talking about some important physical properties of acids. What are the important physical properties of acids? Physical properties of acids. Most important physical property of acids is their taste. Acids have sour taste. Sour taste. But remember, children, it's very harmful to taste the acid, as these are very harmful. They may cause, problems in the internal system of an organism. If people taste it, it may cause burns. Second point is, acids turn blue litmus to red. This is one of the most important properties of acids. Acids, red, danger. Remember this. What is blue litmus? What is this litmus? Actually, how can we know about acid or base? There are certain things, certain substances that help us to know about the acid and base. These are called indicators. And litmus is an indicator. It tells us about whether a given solution is acid or base, as we don't know. The solution does not say that I'm acid, I'm base. We have to judge it. We have to know it. And which helps us? Litmus. Or we see indicators. There are various indicators that we will be talking later. Litmus is an indicator, and there are two types of litmus. One is blue litmus, and the second one is red litmus. When blue litmus is dipped in acidic solution, it turns to be red. Number 3 point. Acids are electrolytes. That means they conduct electricity. How they conduct electricity? You know that HCl. When HCl is dissolved in water, it will form H positive ion and Cl minus ion aqueous. It is surrounded by water. These are ions. Ions conduct electricity. When ions conduct electricity, it's an acid because the ions are coming from this acid. When we dissolve acid in water, it forms ions, and ions conduct electricity. That's why these are called electrolytes. Acids are also electrolytes. Fourth important property is the corrosive nature of acids. Their nature is corrosive. That means when we play with the acids, when we are working in the laboratory, what happens? We get burners on our skin. That means they cause burners on the skin. That's why these are corrosive nature. These are the important properties, some important properties of the acids, physical properties. What is first? Their taste is sour. What is second? They turn blue litmus to red. What is third? Their acids are electrolytes. That means they conduct electricity. And what is the fourth important point? That's they are corrosive nature. They cause burners on the skin. When you deal with acid or acid products, you will see that you will skin burn. When it causes burns, then it's corrosive in nature. Now we will be talking about some important chemical properties of acids. There are various important chemical properties of acids, but we will be talking about few. First chemical reaction will be a reaction of acids with metals. Important reaction. What happens when metals and acids react with one another? Have you seen at your home what happens? Yes? Exactly, same happens. I'm talking about simple reaction. This is a metal, it's a zinc metal that we often see, plus dilute hydrochloric acid. I will explain you why dilute, why not concentrated. What happens? You have gone through the reactivity series. What is reactivity series? It is the arrangement of elements or metals in decreasing order of reactivity. What does that reactivity mean? It means that the metals are arranged in order of their ease of release of electrons. The ease with which a metal releases electron easily, that metal is a more reactive metal. For example, we have two metals, potassium and sodium. These two metals, when they are given same conditions, potassium has the more tendency to remove electrons as compared to sodium. I am comparing these two. Potassium has more ability, its speed is more of releasing electrons as compared to sodium. That means the metal which releases electron easily is more reactive, then that means potassium is more reactive as compared to sodium. You know reactivity series. Is zinc more reactive or less reactive than hydrogen? Obviously, it is more reactive than hydrogen. Then what happens? This zinc will kick out this hydrogen from HCl. It will take its position. First chapter, chemical reactions equations, displacement reaction. This is a displacement reaction. Zinc is more reactive than hydrogen. What happens? Zinc will displace hydrogen and take its position. It will form ZnCl2. No, ZnCl. What is left? Hydrogen. A single hydrogen cannot exist. Two hydrogens form, they combine and form a covalent bond and form hydrogen gas. The production of hydrogen gas is shown by up-headed arrow. What happens when zinc is when a zinc metal is dipped in dilute hydrochloric acid? Then zinc chloride is formed and also hydrogen gas is formed. This reaction is also used to produce or generate hydrogen gas. Now see another reaction. We'll take copper plus dilute hydrochloric acid. We are taking the example of copper. We are dipping the copper metal in dilute hydrochloric acid. What happens? Just pause the video and try to answer this question. I hope you people have gone through this and I hope you people have came to the conclusion. Yes, obviously. Copper is less reactive than hydrogen. It will not displace hydrogen from hydrogen chlorine, hydrochloric acid. Copper is less reactive than hydrogen. It will not displace hydrogen from hydrochloric acid. Simply no reaction. This reaction is not possible. Hydrogen has more electron releasing capacity as compared to copper. This is the first important reaction of acids with metals. What happens here? Zinc reacted with dilute hydrochloric acid. It formed a salt zinc chloride plus hydrogen gas. Another example we took, it is copper. When copper metal is dipped in dilute hydrochloric acid, it for no reaction here, no products. Why? Because we know reactivity series guides us about displacement reaction. Reactivity series says us that hydrogen is more reactive than copper. Hydrogen will not be displaced by copper. This reaction is not possible. I also told you that this reaction is used to produce hydrogen gas. You see that hydrogen gas that is produced, how can we detect that hydrogen gas? We will be taking a simple experiment. We will take Wolf's flask. We will take Wolf's flask. In your 10th class experiments, you will see this flask. It has two openings. One opening from A, from the. What we will do, we will put dilute HCl in this. Okay, and we will add zinc metal in this Wolf's flask. In this Wolf's flask, we will cover this. It's one opening. We will cover this by cork, and here we will put inverted test tube. This is a simple experiment. What happens? Reaction will occur here. Reaction will occur. What reaction will occur? Zinc plus dilute hydrochloric acid gives zinc chloride plus hydrogen gas. Hydrogen gas will be formed. When hydrogen gas will form, it will be seen as bubbles. It will escape this vessel and come in this test tube. When it will get collected in this test tube, what we will do that, we will place a matchstick near the mouth of this test tube. When we place a matchstick near the mouth of this test tube, like this, we have this test tube, it is inverted. If we try to put it in this direction, the gas will escape because the hydrogen gas has low density, it will escape. We have to tilt it like this, bring it and lit matchstick. When you put the matchstick in the mouth, at the mouth of this test tube, you will hear a sound. Yes, you will hear a sound. That sound is called pop sound. Pop sound. You will hear a pop sound. You will hear a sound like this. When you hear the sound like this, this confirms that there is hydrogen gas. The hydrogen gas has been prepared, synthesized. This is the reaction that is used to synthesize or prepare hydrogen gas. And hydrogen gas is detected by a famous test known as pop sound test. What is pop sound test? Whenever there is hydrogen in any container, whether it may be Wolf's glass itself or it may be any other vessel, what we are going to do, just lit the matchstick or any other thing that you have near the mouth of this where there is hydrogen. It will produce a sound that's called a pop sound, and this confirms the presence of hydrogen gas. This is one of the important reactions about reaction of acids with metals and the production of hydrogen gas. And you will do this experiment in the chemistry lab of 10th class. This is one of your experiments there. Now another reaction that we are going to talk about is number 2 reaction. Reaction, I will represent reaction by or action. Reaction of acids with metal carbonates and metal hydrogen carbonates. Again, an important reactions of acids. What is metal carbonate? Simple example. Take the example of calcium carbonate. Calcium is a metal. Since calcium is a metal and this is a carbonate group, we call this metal carbonate or calcium carbonate. Okay, this is the formula of marble or chalk, or the egg of shell of egg. Shell of egg also contains this calcium carbonate. What is metal hydrogen carbonate? Metal hydrogen carbonate is like this. Take the example of sodium hydrogen carbonate. Sodium is metal, this is hydrogen. It is sometimes read as sodium bicarbonate or sodium hydrogen carbonate. What happens when acids react with metal carbonates? Take the example of HCl dilute. What happens? See this reaction. Whenever you see, this is a tricky one here. Let's see the truth. Whenever you see the carbonate group attached to something, and you are doing a reaction, and generally speaking, the one product will be the carbon dioxide gas, and there will be formation of water, and the calcium will combine with chlorine, and it will form calcium chloride, salt plus water and plus carbon dioxide. Same happens here. If we put it in dilute hydrochloric acid solution, what happens? Same thing are produced, carbon dioxide gas plus water, and there is formation of sodium chloride, metal non-metal part. It will form sodium chloride. This what happens when an acid reacts with a metal carbonate or metal hydrogen carbonate, then a salt, water and carbon dioxide are produced. Again, important reactions. Why? Production of carbon dioxide gas. This reaction is used to synthesize carbon dioxide also. And this carbon dioxide is not supporter of combustion. When this is not supporter of combustion, we use it for fire extinguishing. As extinguisher, fire extinguisher. What happens? We took calcium carbonate in one chamber and dilute hydrochloric acid or any other acid in other chamber. When there is an emergency, that fire broke up, we allow these two reactants to react. When they react, they will produce carbon dioxide. When carbon dioxide is produced, it will stop the process of burning. And also, this is one of the importance of this chemical reaction. Okay, students, today we will finish only two reactions, and later on in the another section we will finish the rest. Thank you, and please stay safe, stay home. Fi amanillah.